Hello, my dear students, friends. How are you? Fine. Very good. Today our discussion is finding equivalent resistance by the method of symmetry. Okay. You know the basic formula when two resistors are connected in series. What will be the equivalent resistance? And what will be the equivalent resistance when two resistors are connected in parallel? But in case of the mixed grouping of resistors, we have a lot of complicated figures in our day-to-day life. To solve that, and we need to find that one equivalent resistance, so we need to have different techniques. Out of these, we can, if it is in the form of Wheatstone bridge, balanced Wheatstone bridge, okay, it will be again some easier. Okay, in that context only we are going to discuss some techniques only. That is a method of symmetry. There are basically three methods of symmetry: point symmetry, line symmetry, and plane symmetry. Okay, we will discuss all these techniques. Other than this, also star delta method is also there. We will be discussing in another video. So basically we are going to discuss today method of symmetry. Okay, method of symmetry. First we will discuss line symmetry. Second, we will discuss plane symmetry, and lastly we will discuss point symmetry. Okay, point symmetry. Okay, first, what is line symmetry? Okay, let us see. Line symmetry, we will understand it with the help of some examples only. No problem, you just keep on writing. As always, you write whatever written on the board. Okay, you just maintain the momentum. Okay, what is line symmetry? Say for an example, we have a network of resistance of this type. Okay, say this is one resistance, this is another resistance. Okay, this is another resistance, this is another resistance. Okay, then you can put one more resistance here. Say this is another resistance, this is another resistance, this is one resistance, this is one resistance. Okay, all the values of resistors are R. Okay, say for example, and what is the equivalent resistance between A and B? Okay, and you will find none of them are in series and none of them are in parallel on your first sight. Okay, if you see, are you getting my point? So it will be a little bit confusing to find out the equivalent resistance of this network. Okay, but using the concept of line symmetry, we can easily find out. Okay, what is the concept of line symmetry? First you need to know line symmetry. You have to draw a line, okay, perpendicular to the line joining the 2 points A and B, about which the resistance is to be found out. Now I am going to find out the resistance between A and B, so this is the line joining A and B, and I need to draw the line, symmetrical line, which is perpendicular to A and B. So this is the imaginary line, symmetrical line. Okay, this is the symmetrical line. First thing, remember, this should be perpendicular to A and B, and this should be symmetric also. It is perpendicular. Okay, just take the feel of the perpendicular. Okay, take the feel of the perpendicular, nothing else. And whether it is symmetrical or not, you see, on this symmetrical line there is a resistance R, and on the right side also exactly same position, another resistance is R. Okay, it is symmetrical. For this, it is behaving like a mirror. If it is an object, it is the image. If it is an object, it is the image. Are you getting my point? So exactly that way, if it is R, if it is 2R, then it will not be symmetrical. Okay, but if it is 2R, it is also 2R, then again it will be symmetrical. Good, you know these things. So what I need to do, first step क्या है? What is the first step? Draw a symmetrical line. Draw a symmetrical line perpendicular to the line joining the 2 points about which you need to resistance to be calculated. Okay, this is the step 1. Step 1. So I have drawn it. Then what is the second step? The theory says every point on the symmetrical line will be at the same potential. Every point on the symmetrical line will be at the same potential. Okay. Every point on the symmetrical line will be at the same potential. After that only you can write every point on the symmetrical line will be at the same potential. Okay, what does it mean? What does this line mean? Okay, it means that the potential of this point and potential of this point and potential of this point, all these points will be at the same potential. So if they are at the same potential, it means no current will be flowing through the resistor, because we understand that to flow current through a resistance there needs some potential difference. But here, as it is the symmetrical line, so no current will, all the points will be at the same potential. It means no current will be flowing. As no current will be flowing, this resistance will offer, this resistance will be of no use. As current is not there, what is the meaning of opposition? So this resistance also will be of no use. Okay. If there is no resistance also, if there is a wire only, then also you can remove it, because no current will be flowing through it. It means step 2. What is step 2? Step 2, you can join all the points at the same potential, or you can disjoint according to your wish. If you want, you can disjoint whatever what I have done it. Okay. In fact, you can join also. You can directly join these points like this. You can directly join these points like this. Okay. Why? As the 3 points here, I have got 3 points. You may get multiple points. As all the points are at the same potential, no current will be flowing through them. If you disjoint, then also there will be no problem. If you join, then also there will be no problem. But there is a benefit of doing this, that you will be knowing which one is with parallel with which one, or which one is with series with which one. Okay. Say after joining all the 3 points, it is clear that these are parallel. These are parallel. If we disjoin all, I have disjoined. Okay. Initially the resistance was there, but I have disjoined. After disjoin all these things, it is seen that these and these are in series, these and these are in series, these and these are in series, and this line and this line will be parallel. Are you getting my point? So you will be easily calculating the equivalent resistance between A and B. Are you getting? A complicated situation becomes very easier now. So what is that step 2? We can join or disjoin all points at the same potential. Preferably you should write the 2 steps. Okay, first step, what? Draw a symmetrical line perpendicular to the line joining the 2 points about which resistance is to be calculated. This is the 2 point about which resistance is to be calculated. You see, this is itself is a symmetrical line. It is itself is a symmetrical line, but we do not take this as symmetrical line. We need to take a perpendicular one, means this one. Okay, and what I get, every point on the symmetrical line will be at the same potential. This is the symmetrical line, all points are at the same potential. So as all points are at the same potential, no current will be flowing. So if you want, you can disjoin. If you want, you can join. Are you getting? Now picture is clear. RR series, RR series, RR series. This parallel. Whatever answer you get, I think the answer will be 2R by 3 in this figure. Na? 2R, 2R, 2R. And all together it will be 2R upon 3. Okay. If you join also, then also you are going to get 2R by 3. If you have joined, you have joined it. Okay? And you have joined this. Now this is R. So this part is R by 3. This part is R by 3. R by 3 series. It means 2R by 3. Are you getting my point? In this answer, in these questions, equivalent resistance, you have got 2R by 3. So in another situation also you can apply this type of techniques. Okay. Let me give you one question of this where I can easily use that method of symmetry. Okay. Say I have a network of this type. Okay, it has a resistance R, it has R. What is the resistance between A and B? Okay, find RAB. Using that line symmetry concept, we can easily do it. What is the line symmetry concept? First you try, give a pause on the video, then compare with me. Okay, it will be a symmetrical line. Okay, left side it is R, it means R by 2 left side, R by 2 right side. This is also R, it means R by 2 left, R by 2 right. Okay, now all the points are at the same potential. Now you see, if I draw this part like this, I think then also there will be no problem, because this point and this point are already joined. Okay, now also it is joined, but now I see that it is a part of the symmetrical line. It means this point and this point will be at the same potential. So if I want, I can cut this connection, because I know no current will be flowing from top to bottom, yeah, bottom to top. So I have cut it. So after just cutting this connection, what I see this and this will be series, and the net resistance will be parallel to this. This and this will be series, and the net resistance will be parallel to this. Are you getting my point? So what will be the equivalent figure of this? This is A, this is R, this is 2R. When R and 2R are parallel, so net result is 1 into 2 by 1 plus 2. It means 2 by 3 R. So this part is 2R by 3. Okay. This is 1R, it is 2R. So 2 into 1 by 2 plus 1. I have given you that shortcut, na? That is what 2 upon 3R. That is also 2R upon 3. And I have already told you that when two equal resistors are parallel, these two will be parallel easily. And the resultant is half of either. No? So what will be the net result? It is equivalent to simply 2R by 3 divided by 2 means R by 3. Are you getting my point? So the net resistance between A and B will be R upon 3. So you can apply this type of shortcut techniques. No? Some students make this mistake here. Why not understanding the concept properly, what he or she may do. Many students do this mistake. That is why I am just giving you the warning so that you don't do this mistake. Many students do this mistake. Initially the wire was connected this way. Now they will redesign it this way. Okay. Now they will disjoin this part. Okay. If you do this, you are doing blunder. Okay. You are doing a big mistake. You see, you can't remove this wire. How? Because symmetrical line is this. So current will not flow from top to bottom or bottom to top. But it says that removing this, you say that current is not flowing from left to right or right to left. Are you getting my point? This is not a symmetrical line. Though it is a symmetrical line, but not the desired symmetrical line. Our desired symmetrical line should be perpendicular. No? So that condition is violated here. No? That is why. Actually the figure will be like this. Okay. That is the way how to solve problems using line symmetry. So let me now discuss the plane symmetry. Okay, plane symmetry. Plane symmetry we can use in basically 3Ds, three-dimensional figures. What is plane symmetry? Plane symmetry. Okay, let us consider a figure. So this is a cube. All the branches have resistance R. All the branches have resistance R. Okay, no need to draw. You understand all these things. Okay? All the branches have resistance R. Say this is A, B, C, D, E, F, G, H. Okay. What is this? Cubical frame having all the branches a resistance R. Okay, and what I need to do, I need to find out the resistance between any edge. Okay, this and this. Okay, say D and C. What is the resistance between D and C? I need to find out. Remember, if you find out the resistance between D and C, then no need to find out the resistance between A and D. It is a symmetrical figure, the answer will be same. Between A and B also, the answer will be same. If you apply a battery between D and C, the current will flow. Current will get in this way and get out that way. Nah? So what is the net opposition? You need to find out. That is the main concept of asking that equivalent resistance. So using plane symmetry, how can I do it? See, this type of problems. First, step 1. Step 1. Draw a symmetrical plane containing the line joining the 2 points about which resistance is to be found out. Draw a symmetrical plane containing the line drawn between the 2 points about which resistance is to be calculated. What does it mean? Let me explain once more. About which the resistance will be calculated? About D and C. So D and C is a line. Taking this line, you have to draw a symmetrical plane. Remember, the plane should be symmetrical. So let me draw it. This will be my desired symmetrical plane in 3D view. You try to understand which plane I am talking about. I am just dividing the cube across its diagonals. Look at this, and this symmetrical plane is drawn taking the line DC. The first thing is, it is a symmetrical plane because it is passing midway the cube. Okay, good. I hope you have seen it, you have viewed it three-dimensionally. Okay, if the symmetrical line is behaving like a mirror, then if A is object, H will be its image. Is it? Yeah, vice versa. If H is the object, A is its image. Is it? Because mirror is midway, na? Then can you say, if B is the object, what is its image? Z. Very good. Z. For B, Z is the image. For A, H is the image. So what we need to conclude from this? Conclusion is that the object and the image are at the same potential. That is a technique, I have told you only. The object and the corresponding image will be at the same potential. Remember, you need to learn this thing. In line symmetry, all the points on the line at the same potential, but in plane symmetry, object is at the same potential with the corresponding image. It means A will be at the same potential with H, B will be at the same potential with Z. Okay, that is from step 1. What is step number 2? I am going to rub it. Step number 2. Join all the corresponding symmetrical points. Okay, see, now A and H was same potential, so I can join it. If I join, then also no current will be flowing from A to H and B to Z. Are you getting my point? But while joining now, we will be benefited. We will be knowing which one will be series with whom. Okay, all this thing will be clear. Just let me redraw this figure. And in some cases now, if they are already joined, you can disjoin also. Whether you will join or whether this will disjoin, it depends upon you only, which will give you a clear picture. so that we can find out the equivalent resistance. Okay, now you see D and C. Let me draw D and C. It has resistance R. Okay, from D I need a resistance to A. From D I need a resistance to A. This is the A point. Okay, from D I need a resistance to H. From D I need a resistance to H, and A and H are joined, so this is a single point. It means you have crossed the figure about their symmetrical plane. A will be overlapped with H. Similarly, from C there is a resistance to B. There is a resistance to B. From C there is a resistance to Z. But B and Z you have joined. It means this is B and this point is B or Z. Are you getting? Now you see from A to E another resistance is there. From H to E, because this point is H itself, na? This point is A also, H also. Another resistance is there. Similarly, B to F, and Z to F. Okay, and EF. You see, all are resistance. This is also resistance. This is also resistance. This is also resistance. This is also R. Everywhere R resistance is there, and here also. Okay, and two resistors we are missing now. Which? From A to B. From A to B, there is a resistance. One more resistance we have missed. H to Z. Okay. Now you see the picture is quite visible. It is clear which one is in series with whom. Okay. See what will be the equivalent figure of this. Let me draw it. Because that one and that one was same, na? Let me draw it. These two will be in parallel. It means R by 2, R by 2, R by 2, R by 2, R by 2. So let me draw once more. This is D, this is C. 1 R. This is R by 2. 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 This is R. This is R by 2. Are you getting my point? Check it. Okay. Then what is the next figure? This is D. This is C. This is R. Okay. And these three are in series. So it will be R by 2, R by 2. Means 2R. Okay. R by 2, R by 2, R. Or R plus R, 2R. So let me draw this. This is R by 2, this is R by 2, this is R by 2, and this is 2R. This is 2R, this is R by 2, this is R by 2, and this is R by 2. Check it once more. Now I think you should try. Okay, you should try to find out the equivalent resistance between D and C, because these 2 and half will be in parallel again. So what will be the next step? If I calculate it, this is 2 and this is half are parallel. What will be the equivalent resistance? 2 into half by 2 plus half. When two resistors are parallel, so this is the best technique to calculate. A into B by A plus B. R1 into R2 by R1 plus R2. Okay, so this will be 1 and this will be 5 by 2. It means 2 by 5R. Okay, so what will be the equivalent? This is R, this is R by 2, and this is 2 by 5R. This is R by 2. This is D and C. Are you getting my point? Okay. I need some space. I am going to rub it. So after this figure, this and this will be in series. Okay, R by 2, 2 R by 5 and R by 2 will be in series. So what will be the equivalent figure? This is D, this is R. Okay, this is C. Now there is a single resistance I can put R by 2 plus R by 2, R plus 2 by 5. The 1 plus 2 by 5. What will happen? 7 by 5 R. Okay. So finally we are getting 7 by 5 R and R parallel. Okay. 7 by 5 and R are parallel. So after that, what will be the next equivalent figure? This is D and this is the equivalent figure. Okay, this is R equivalent. So what will be the R equivalent? R equivalent is these two are parallel, so it means 7 by 5 into 1 by 7 by 5 plus 1. Okay, so what will happen? 7 by 5, 12 by 5 into R. Everywhere R is there. 5 got cancelled, means 7 by 12. 7R by 12 is the answer. Okay, so that is the way how can I find out the equivalent resistance using the technique, that one, plane symmetry. Okay, for you one homework you can take, I'll rub it, or you can take one homework in the same figure. You try same cube. Okay, all branches have resistance R, A, B, C, D, E, F, G, H. Okay, I have found the resistance between D and C, equivalent resistance. Now you find out the resistance between D and Z using that plane symmetry. Okay, find resistance about D and Z. Okay, all the branches have resistance R. All the branches have resistance R. Okay, what you need to do, you draw, first you join this line DZ and you draw a symmetrical plane passing through the line D and Z. Are you getting a point? I think the 3D view is clear. I have drawn a plane which is bifurcating the cube equally and passing through DZ. Okay, then which one will be the object, which one will be the image? Check it. For E, B will be the object or vice versa. For H, C will be the object or vice versa. And what is the second case? I can club them, I can join. Yeah, I can cross the figure about the symmetrical plane. So B will be overlaid with E, C will be overlaid with Z. So what will be the equivalent figure for this? You have to put D and Z sideways. Then D, from D to C, this point is C. Then D to H. D to H means this point is C also, H also, as C and H are connected. Then C to Z, C to Z, H to Z, H to Z. Okay, this part is over. Then D to A, D to A, this point is A. Then Z to F, so this point is F. Then A to E, A to E, this point is E. Then E to F, okay, this point is E. A to B, A to B, so this point is B also, because B and E are clubbed. Then B to F, okay, and again two resistance I have not drawn here till now. What is that? E to H, E to H, B to C, B to C. Okay, so this is the comparatively थोड़ा easier figure to find out equivalent resistance. Now you see in this figure I need to find out the resistance between D and Z na? Now you can apply the symmetrical line concept. If I apply the symmetrical line concept na, so these two resistance will be useless. Okay, now this and this will be parallel, this and this will be parallel, this will be series, this all those three, all resistance are series. Okay, this parallel, this parallel, this series, this series, and this line will be parallel. Okay, rest part you please do. Okay, so this is the technique actually I have just shown you. Now I am going to point symmetry. Let me discuss something about point symmetry. Last, point symmetry. What point symmetry? Say I have a figure like this, another resistance, this, okay, and this, okay, this, okay, like that. Just I'm drawing all these things. Okay, what is the resistance between A and B if all individual resistors are R? Okay, what is the equivalent resistance between A and B? Using point symmetry technique we can solve all these things. See, I need to find out the resistance between A and B. It means you are imagining a battery connected from A to B. Current will go. Okay, now you see the current will be divided into three parts, 1, 2, 3. But now question is whether the current will be equally distributed. You have to check it. Whether will the current be distributed equally, you need to check it. See, say this current is coming this way and getting a resistance R. Then after that it will be bifurcated into two parts. You can see the number of paths through which this current go to reach B is same as the number of paths through which this current will go. The number of paths 1, 2, 3. Okay, there are a lot of paths for I1 to reach B. Exactly that way, the number of paths for I2 also identical. You see, if it has total 8 paths, it is also have 8 paths. If it gets this type of resistance, this I2 also gets similar type of resistance. It means it says that I1, I2 will be same. It means the value of I, the current here and the current here will be same. Then you see, if current is same, resistance also same, means voltage drop here will be same. Voltage drop here also will be same. Now you see, if the voltage drop is same, then the voltage left, say total voltage it is 10. Out of 10, 2 is dropped. To left is 8. Then the voltage left is also same. It means this point will be at the same potential. They are symmetrical points. Are you getting my point? So that is why I need to redraw this once more, this figure. That way you see this point and this point and this point will be same potential. They are symmetrical points. Exactly that way this point and this point will be at the symmetrical. There will be the symmetrical points. Are you getting? Symmetrical points are at the same potential. The conclusion is that the symmetrical points are at the same potential. You write down symmetrical points are at the same potential. If they are at the same potential, if you want you can disjoint, if you want you can club them. Okay, here I am going to disjoint because no current will be flowing from this to this. No current will be flowing from this to this. Exactly that way I can disjoint this. I can disjoint this. these 4 resistors are of no use. Now the picture is clear. R, and R. These 3 are in series. R. This line in series. R. These 3 line in series. So 3R. So that resistance between A and B is 3R upon 3. It means R. Okay. The equivalent resistance is R. 3R. All 3 are in parallel. So you can use the formula. You can easily find. The answer is R only. Okay. So this is the techniques we can use. Are you getting my point? For calculating equivalent resistance. If there is a problem, you just rewind the video several times. I'm sure you will understand it and you will be able to apply all these techniques. Is it okay? Good. Thank you.